If your engine feels slightly weaker than it used to, if your fuel economy has quietly dropped, or if your car hesitates for a fraction of a second when you accelerate, you are not dealing with random wear. You are dealing with inaccurate data. And that difference matters. Because modern engines do not fail the way older engines did. They do not simply break. They drift out of precision, step by step, until the damage becomes visible. At the center of that process is a small component that most drivers never think about. A sensor that usually costs less than $25. A sensor that almost never triggers immediate concern. And a sensor that, when ignored, can quietly affect everything from combustion quality to long-term engine wear, and even exhaust system damage. Most people only hear about it when it fails completely, but by then the consequences have already spread through the system. Drivers who understand how this works do not wait for that moment. They deal with it early while the problem is still small, controlled, and reversible. The component is the mass airflow sensor, or MAF sensor. Its role is simple to describe, but critical in function. It measures the amount of air entering the engine, so the system can calculate the correct amount of fuel to inject. Every combustion cycle depends on that calculation being accurate. If the air measurement is off, even slightly, the fuel mixture becomes incorrect. That affects efficiency, temperature, and the way the engine behaves under load. The important detail is not just what the sensor does, but how it does it. Inside the MAF sensor is a heated microscopic element, often called a hot wire. Air passes over this element, and the sensor measures how much it cools down. That cooling effect is used to calculate airflow. It is a precise system, but also a sensitive one. Because that element sits directly in the intake stream, it is constantly exposed to everything flowing into the engine. Over time, a thin layer begins to form on that surface. Oil vapors from the crankcase ventilation system, fine dust particles that pass through the air filter, microscopic contaminants from the intake system itself. Individually, these particles are insignificant. Together, they create a coating that changes how the sensor reacts to airflow. The sensor still works. It still sends signals, but those signals are no longer accurate. Even a small deviation at this point is multiplied thousands of times per minute as the engine continues to run. And this is where the real problem begins. When the MAF sensor sends slightly incorrect data, the engine control unit does not shut down or throw an immediate fault. It compensates. Fuel delivery is adjusted to match the perceived airflow. Ignition timing shifts to maintain stability. The system adapts to maintain operation using flawed input. At first, the changes are subtle: slightly higher fuel consumption, a small loss in responsiveness, a mild inconsistency under acceleration, nothing that clearly points to a specific failure. But over time, these small inaccuracies start to create larger effects. When the fuel mixture runs richer than it should, combustion leaves behind more carbon deposits inside the engine. Those deposits build up on intake valves, pistons, and combustion chambers. When the mixture runs lean under certain conditions, temperatures rise, increasing stress on internal components. At the same time, incomplete combustion allows small amounts of unburnt fuel to enter the exhaust system. That fuel reaches the catalytic converter, where it burns at extremely high temperatures. This accelerates wear inside the converter, slowly degrading its internal structure. A problem that started in the intake system has now moved all the way to one of the most expensive components in the vehicle. Modern vehicles make this harder to detect. Instead of exposing the issue early, they are designed to adapt. The system adjusts fuel trims, compensates for deviations, and keeps the engine running smoothly enough that the driver does not immediately notice a problem. There is no clear failure point, only gradual deviation from optimal performance. By the time a warning light appears, the system has often been operating outside ideal parameters for a long time. And at that stage, cleaning the sensor may no longer reverse all of the side effects that have already built up. This is why treating the MAF sensor as a part that only matters when it fails is the wrong approach. It is not a failure-driven component. It is an accuracy-driven component. It does not need to break to cause problems. It only needs to become slightly inaccurate. In most cases, the sensor itself is not damaged. It is simply contaminated. And that leads to a simple but overlooked solution: cleaning. The reason most people ignore this step is because they assume cleaning is either unnecessary or risky. In reality, it is both effective and safe when done correctly. The issue is that many people use the wrong method. They use aggressive cleaners not designed for sensors. They physically touch the internal element. They try to wipe or brush away contamination. That approach does more harm than the contamination itself. The internal wire is extremely delicate. Any physical contact can damage it permanently. The correct method avoids all of that. Remove the sensor carefully from the intake housing, making sure not to touch the internal element. Use a dedicated MAF sensor cleaner, formulated to evaporate quickly and leave no residue. Spray the cleaner onto the sensor from a short distance, allowing it to dissolve and wash away the contamination. Then let the sensor air dry completely before reinstalling it. No wiping, no brushing, no compressed air. Just a controlled cleaning process that restores the sensor's ability to read airflow accurately. The entire process takes only a few minutes and costs very little, yet it directly affects how your engine calculates fuel, manages combustion, and maintains efficiency. The important part is not just doing it once, but understanding why it matters. This is not a repair. It is maintenance that prevents a chain of small errors from turning into larger mechanical problems. Ignoring it means allowing inaccurate data to control every combustion cycle your engine performs. Drivers who maintain this sensor regularly avoid many of the issues that appear unpredictable to others. They do not see sudden drops in fuel economy. They do not experience inconsistent throttle response. They do not face premature stress on components like the catalytic converter. Not because their vehicles are different, but because the system continues to operate with accurate input. If you take one idea from this, it should be this: engines rarely fail without a cause. They move away from optimal operation gradually, and small inaccuracies in key sensors are often where that process begins. Maintaining those sensors keeps the entire system closer to how it was designed to function. If you want to stay ahead of these kinds of hidden issues and understand how modern engines actually behave over time, subscribe. Because this sensor is only one part of a larger pattern. There are other components that degrade in the same way, create similar chain reactions, and cost significantly more when ignored. And most drivers never look at them until the damage is already done.